Here's our next fact about R squared. R squared will be exactly equal to 1 when the number of parameters you're estimating is equal to the number of data points. And of course, by the time that happens, you are vastly overfitting. So it turns out I've already given you an example where this is happening. If we go all the way back to this slide here, here the number of data points is 3, and the number of parameters that I'm estimating, well, let's see, beta 0, beta 1, beta 2, also 3. So this was a case where the number of data points equals the number of parameters, and look what happened. For each person, my fitted value is exactly equal to the one in the data set, right? So for this person who's a first year, let's summarize this model just to be clear here. This model, my best guess at this model was 5 minus 4 times whether you're a junior, minus 3 times whether you're a senior. So my fitted value for the first year, let's put it in the fitted value column. Remember, we call those y hats, the fitted value. My fitted value for the first year, well, that person's not a junior, not a senior, so the fitted value is exactly fine. Fitted value for the junior, okay, so it's 5 minus 4 times 1 minus 3 times 0, so it's 5 minus 4 equals 1. And for the senior, well, it's 5 minus 4 times 0 minus 3 times 1, that's going to be 2. So the residuals are all 0. Why did that happen? Because the number of data points was exactly equal to the number of parameters in the model, right? Therefore, the sum of squared residuals is going to be 0. Therefore, 1 minus sum of squared residuals over sum of squared total is 1. The R squared is 1 when the number of predictors is equal to the number of terms in the model. I'll try to show this to you in a more general way as well. So suppose, also with just n equals 3 though, because I think that it's a good sample size to be working with. So suppose these are my data points. I've got x1, y1, so it's the x and y value for the first person. I've got x2, y2, and I've got x3, y3. Right? Suppose that's my data set. All right, and suppose my model that I'm going to run is that the mean of y given x is beta 0 plus beta 1x. I'm going to stop this video here. I should put it off before I start writing on this slide. Let me try to show you in a more general way. First, where we have n equals 2. So suppose that I have the first person's values, x1 and y1, and the second person's values are x2 and y2, and that's my little data set. And suppose that my model is that the mean of y given x is equal to beta 0 plus beta 1 times x. Suppose that's my model. Okay, so how am I going to do this? Well, let's see here. To solve for beta 0 and beta 1, because of course that's my goal, I'm going to plug my data points into the model. So I'm going to have, well, y1, the first person's outcome, is going to be equal to, as close as I can come, to intercept plus slope times x1. Like I'd have a 0 residual if this equation was true, right? So let's try to make that equation as true as possible. And the second person's outcome, well, ideally, if the residual was going to be 0, I'd have beta 0 plus beta 1 times x2, right? A second person's predictor times beta 1 plus an intercept would equal the second person's outcome. Now, I'm saying ideally, but the whole point here is it's not really ideal to have 0 residuals. It's overfitting. But looking at this, notice that I have 2 equations, right? See them? I've got equation number 1 and equation number 2, and 2 unknowns. right? Beta 0 and beta 1. And if you think back to high school, that should be a familiar phrase, 2 equations, 2 unknowns. If you have 2 equations and 2 unknowns, you can solve exactly, right? It's possible to solve these equations exactly for beta 0 and beta 1, such that both these equations are true and therefore the residuals are 0. With 2 equations and 2 unknowns, can find beta 0 and beta 1 such that these equations are perfectly true and therefore residuals are 0, okay? Which implies that R squared would be equal to 1. And this is happening, again, because I have 2 data points, but only 2 parameters I'm estimating.